What's up, everybody? It's Coach Sharf. Welcome back to my YouTube videos on our class notes. Today we are picking back up with the factors, roots, and zeros my packet. That's the packet we've been doing in class for factoring polynomials and finding the roots of polynomials. So if you need to go back and watch the first video, we did the first part of the packet, which was mostly background information, stuff we've already learned about factoring quadratics, doing the quadratic formula, although I think I skipped those problems like I did in class because we should know how to do the quadratic formula by now. Using synthetic division and then using the rational root theorem. So we're going to pick up in the actual problems. And again, these are the problems that you're going to take pictures of and submit for your grade. I'm going to break this up into two videos because if I try to do all 7 in one video, I feel like it'd be a little long. So the first video is going to be question 5, parts A, B, and C, which are all cubic functions. I'm going to go a little slower in this video. And then the second video will be part 6, A, B, C, and D, which is 2 quartic functions, x to the 4th, and 2 quintic functions, x to the 5th. And I'll go a little faster in those, but let's go ahead and get started. Oh, went to full screen on accident. All right, and I'm not sharing either. I would share. All right, so I'm gonna slide back up here. We'll just quickly kind of remind y'all, if you're watching this right after the last video, the last thing we did in the last video was the rational root theorem, and we did it with this polynomial. X cubed minus 5x squared minus 4x plus 20. That's actually the polynomial that we're going to start with down here. Okay, so for 5, you can write number 5, and then where it says use the quadratic formula, we're going to cross that out and put factor and find roots. Depending on what class, if you've been doing this a lot with me in class, I either put of cubic functions or of polynomials. I'll put cubic functions for now because that's what part 3 or that's what part 5 is. And then like I said, part 6 is quartic functions and quintic functions. All right. So for each of the following, find the roots, classify them, and show the factors. So again, the whole idea about the rational root theorem is it's basically I'm trying to find any number I can perform synthetic division with because I'm not told what to divide this by. All right. So to do my possible rational roots, that's the P over Q. But I got to identify P and Q. So I'm going to put a P above 20. A Q, it's not good like a Q. A Q above my invisible 1 on x cubed. So now I got to say, all right, P is all my factors of 20. What can I multiply to get 20? 1 and 20, 2 and 10, 4 and 5. So those are numbers I'm going to write, but I'm going to write them in order, ascending order. Okay. 1, 2, 4, 5, 10, and 20. All right. Q. All my factors of my leading coefficient, the coefficient on my first term. I do not have a coefficient out there. So again, we're going to treat it like an invisible 1. What are my factors of 1? Well, it's just 1. 1 times 1. All right. So I'll put plus or minus 1 for Q. So for P divided by Q, that's exactly what you do. Okay. Divide all your P's by all your Q's. Again, the plus minus signs are always going to be there. So we're just doing 1 divided by 1, 2 divided by 1, so on, so on, so on. So it's all exactly the same. Okay. 1, 2, 4, 5, 10, and 20. And this is where I'm going to discuss, it's not a shortcut because we're cheating anything or, skipping any steps, more of a logical shortcut. When Q is 1, okay? When you write P and Q up here and Q is 1, you know, you're going to take all your P's, divide them by 1 and get the same thing. So you can really, you know, kind of skip this step going forward. If we put P and Q up here before we write them out, we know Q is 1. We can skip this going forward. We only have to write P divided by Q. Then it's just going to be whatever my factors of P are. Because all my factors of P divided by 1 would be the same thing. So that's what we're going to kind of look at going forward. But I guess I should have said that in case y'all are following along and scratched it out. Leave this written for this problem, but going forward, we'll just do that. So I hope y'all didn't scratch that out with something you can't erase with. If you did, I apologize. So I said this in class too. Again, I'm going to work through it. You can try to follow along if you can, but what I'm going to do is once I get through the whole problem, you know, I want you following along, paying attention. And even as I say this, I know some of y'all are about to do what I'm going to warn you not to do. And that is just to get to the end of this problem and write down everything you write down. You need to see me work through it so you understand what you're doing. So, you know, if you actually watch the video and watch what I'm doing, you can do that and focus on that without having to write. That's fine. And then when we get to the end of the problem, then you can write it. Or again, you know, you can kind of stop along the way and write if you want to as well. So we got all of our P over Q's, okay? These are the 12 numbers, +1, -1, +2, -2, so on, so on, so on. That I'm going to try to use to perform synthetic division. Okay, so that's the first step I got to do. I got to use synthetic division. I've talked about it as we've been doing this packet. Got to use synthetic division to break down our polynomials, okay? If we start with x to the third, I got to do it once to break it down to x squared. If I start with x to the fourth, I got to do it twice, break it down to x cubed, then break it down to x squared. If I have x to the fifth, I'm going to have to do synthetic 3 times because I have x to the fifth, then x to the fourth, then x cubed, then x squared. So, since this is x cubed, I only need to find one synthetic division number that works, okay? So, you know, if you were paying attention in class, I told y'all that, you know, if you do this in class, you might want to, or if you're doing it in the packet, you might want to use some scratch paper to do your synthetic division until we find a number that works, because even though we're just looking for one synthetic division that works, if +1 doesn't work, -1 doesn't work, +2 doesn't work, -2 doesn't work, you know, we don't find anything until we get to +4, you're still going to have to do synthetic division 5 times. You have to try it 5 times to find out one number. So I know we're only going to have to do it 3 times, and I think we can fit that in here. So we're just going to go ahead and go. All right, so I'm going to start synthetic division. Again, I know in the steps I told you I put the L second. I just usually put it first. It doesn't, you know, doesn't really matter, I guess. So we're going to take our numbers that we're going to put on our top row. They're going to be our coefficients and constant of our polynomial. So 1 x cubed, -5 x squared, -4x, and 20. And then we are going to do our box. And in our box is where we're going to put these numbers. So I'm going to start with +1. Okay. I'm going to go a little slower on this video. And then on the next video, I'm going to pick it up. So I drop this one. And it's going to come down here. Now I'm going to do 1 times the black one in the box. And move it over. 1 times 1 is 1. All right. -5 in 1 is -4. All right. -4 times 1 is still -4. -4, -4 is -8. Oh, need to make that blue. -8. -8 times the black one is still -8. And then 20 minus 8 is 12. So I finished this first synthetic division, and I did not get a remainder 0. Again, we're looking for a remainder 0. So that one didn't work. So you can kind of put a slash through it if you want to. All right. So what we got to do is we got to try to do it again. 1, -5, -4, 20. Make our box. And now in our box, positive 1 didn't work. But we got to do -1. Okay. So -1. All right.
My son coaches at University of Houston.
So we drop the 1. Drop the 1. All right. So 1 times the black -1 is -1.
And they recruited the guy. And I thought about you. His last name is Szymanski.
-5 and -1
New Mexico State. And
is -6.
Ask Kelly if she knows this guy. His name is Raphael.
-6 times -1
Yeah, look him up.
is positive 6.
They just recruited.
-4 and 6
Wait a minute.
is 2.
This name is so unusual. Maybe they're related.
2 times -1. That's got to be -1.
Yeah.
2 times -1 is -2.
It did say something about him coming from Poland.
Then
It did say something about
20 minus 2 is 18. I was about to make that in green. So again,
yeah.
did not get a remainder of
Over there.
0. So that doesn't work.
Yeah. Okay.
All right. So now I got to do it a third
I
time.
used to work with another lady, and I thought about her.
1, -5, -4,
Her name was
20.
Szymanski.
Make my box.
Yeah, Szymanski. I was like, wait a minute. I wonder if that's her daughter. And then I looked, I said, oh, it's not the same. It's Szymanski, not Szymanski. Yeah.
And sorry.
Well, thank you.
So now I got to use positive 2.
Well, tell him my age.
All right.
He's 33.
Positive 2.
So that's good. Yeah.
So drop the 1.
Actually, I got a 36 too. My daughter's
1 times my black 2
That's what I said. I said, you already?
is 2. -5 and 2 is -3.
You know, when I lose weight, the only place to lose it is
-3 times 2 is -6.
I lost weight only in my face, and it's picked up everywhere else.
-4 and 6
Yeah.
is -10. -10 times 2, I'm running out of room a little bit here, is -20.
I know, I was looking
And
up
then
at-
20 minus 20 is 0. So there we go. All right, so now that we've done synthetic division successfully,
Okay. All right, well, have a good
2 is my root.
And thanks for helping me.
Again, so this 2, like we said, it's like a root. If I plug in 2 here, 2 cubed is 8, -5, x squared, so 2 squared is 4. 4 times -5 is -20. So I've got 8, -20. -4 times 2 is -8. So 8, -20, -8, +20. It all cancels out to give me 0. So the 2 is my root. That means my factor is x minus 2 because I got to use the opposite sign. Because when I set it equal to 0, what's going to cancel out -2 is the +2. So that's where, that's where it comes in. So got one root, one factor. Now when I go to label this, I have 0 is my remainder, -10 is my constant, -3 is my coefficient on x to the first, 1 is my coefficient on x squared. So I've got x squared minus 3x minus 10. So I got to try to factor this, okay? What two numbers can I multiply to get 10 that I can add or subtract to give me 3? It's going to be 5 and 2. 5 times 2 is 10. 5 minus 2 is 3. Since 10 is negative, that means since I'm multiplying 5 times 2, one of them has to be positive, one has to be negative to get a negative 10 when I multiply. And then, so I know they have to have opposite signs. So then I got to ask myself, what's going to give me negative 3? Positive 5 minus 2 or positive 2 minus 5? It's going to be positive 2 minus 5. So those are going to be my last two factors, x minus 5 and x plus 2. All right, so these are my three factors now, okay? Now to get our last two roots, kind of the same thing we did here. What's going to cancel out negative 5 is positive 5. What's going to cancel out positive 2 is negative 2. So my three roots are 2, 5, and negative 2. So I've got my three factors and my three roots. So again, as y'all are writing this in your notebook, you can write roots and classification. You can write the complete factorization if you haven't. You can write roots and classification. You can write the three numbers. You don't have to write all these columns and then circle, okay? So you could just write what the classification is. So we're going to start with real or imaginary. 2, 5, and negative 2. Those are all real numbers, okay? You know, we see those every day. They're not imaginary. They don't have the eye on them like an imaginary number does. So they're all real. And then rational or irrational. Again, rational is anything that can be represented with a fraction. That includes whole numbers. Irrational cannot be represented with a fraction. And, you know, if you talk about decimals, irrational is a decimal. It doesn't repeat or never repeats or never terminates. In our instance, for when we're using it here, it's basically going to be if I ever have to do the quadratic formula and wind up with, you know, a square root that's not a perfect square. Otherwise, all my answers should be rational. So next to all three numbers, you're going to write real and rational. Real and rational. I know my handwriting is small because I'm trying to fit it into space and it's not pretty, but real, R-E-A-L, and rational, R-A-T-I-O-N-A-L. All right, so again, it looks like a lot of writing, but that's what I need for the first problem. Okay, this is what I need for the first problem. So again, I'm going to leave this for about 15 seconds in real time. You know, y'all can pause and get what you need. And now I'm going to move on to part B. All right. So we'll clear that and we'll move on to part B. All right, x cubed plus 2x squared minus 5x minus 6. So again, y'all can write that, write possible rational roots, P and Q. So this is what I was talking about in the last problem. Q is 1. So I could just skip just straight going to P over Q, save myself a little bit of time. And then what I'm going to put is just my factors of 6. So 1, 2, 3, and 6. So I'm not going to slide it back up, but if y'all remember from the first video or earlier in the notes, again, you know, however you're kind of looking at this, for the synthetic division examples, the example that they kind of did in the packet was with this, and they divided it by x minus 2. But, you know, we're going to kind of look at it from fresh eyes because, again, if you were given this without being told that, it and we're doing the synthetic division, we're actually going to get to a number that works before, we would get to the positive 2, which is what would give me my x minus 2 as my factor. So go ahead and jump into our synthetic. We got 1x cubed, 2x squared, negative 5x, negative 6. Put my box on the outside. We'll start with positive 1 and just dive in. So again, I feel like I've been going a little long. So in the interest of time, again, I'm going to go a little faster now. All right, this 1 comes down. I'm still going to draw the arrows going down, but I'm not going to put my little red ones next to this. I'm just going to say it. Blue 1 times red 1 is 1. 2 plus 1 is 3. Blue 3 times red 1 is 3. Negative 5 and 3 is negative 2. Blue negative 2 times red 1 is negative 2. Negative 6 and negative 2 gives me negative 8. So positive 1 didn't work. Okay, it happens. Next. Do it again. 1, 2, negative 5, negative 6. Put my box. Again, you don't have to circle this like I do, but it's just, again, me trying to show y'all our progression as we go down our whole list. So now we will use negative 1. Okay, negative 1 comes down. Blue 1 times red negative 1 is negative 1. 2 minus 1 is 1. Again, I have blue 1 times red negative 1 is negative 1 again. Negative 5 and negative 1 is negative 6. Then blue negative 6 times red negative 1 is positive 6. Negative 6 and positive 6 is 0. So that one worked. That's my remainder of 0. So again, before I label it, negative 1 worked, so that's my root, which means my factor, again, is the opposite sign. So my factor is x plus 1. Okay. Now to label these, negative 6 is my constant. 1 is my coefficient on x to the first. 1 is my coefficient on x squared. So I've got 1x squared plus 1x minus 6. I again see if I can factor this. Now we're picking up steam a little bit. What can I multiply to get 6? The adds or subtracts to give me 1. It's going to be 3 and 2. 3 times 2 is 6. 3 minus 2 is 1. So again, 6 is negative. So I know 3 and 2 are going to have opposite signs. So it gives me plus 1, positive 1, the invisible 1 on x. 3 minus 2 or 2 minus 3. It's going to be positive 3 minus 2. So those are my last two factors. And again, we're picturing this set equal to 0. So there's where I get the negative 1. What cancels out positive 3 is negative 3. What cancels out negative 2 is positive 2. So negative 3 and positive 2 are my last two roots. And again, I'm just going to write them out this time. If you have the packet printed out, you can circle real and rational. Again, I hope I don't have to say this, but if you're just writing this on your paper as is, the roots and classification, again, you don't have to write, I know I said you don't have to write all this, but just write number 1, real and rational. Write it right here. You don't have to leave a giant space there in the middle. I know it probably sounds obvious, but some of y'all just kind of get in the zone and just, even if I tell you not to write this, you just like, oh, I just need to leave it blank and still put this over there just because you're kind of in a zone, just trying to get it done. So there's that. See, that one is bad. Doesn't seem like there's as much writing on that one. So there's that one. Again, I'll wait about 15 seconds of real time, pause it, catch up where you need to catch up, and then we will move on to part C. All right. Part C. And this is the last problem for this video. I'll cut it off and I will do number 6, parts A through D in a separate video. So C, f of x equals 4x cubed minus 7x plus 3. This one's a little different for a couple of reasons. First of all, I put P, I put Q. I actually have a leading coefficient now that's not 1, it's 4. So in this case, I do have to go back to doing P, Q, and P over Q. So again, P is my factors of 3. I put the P over the 3 because that's what I'm getting my factors of. So 1 and 3. Q are my factors of 4. 1 times 4 and 2 times 2. So 1, 2, and 4. So now for P over Q, it's not just 1 divided by 1 and 3 divided by 1. So that's still what you're going to start with. Excuse me. Then I got to say, all right, now I got to do 1 divided by 2. 1/2. You can leave it as a fraction. 3 divided by 2. 3/2. You can leave that one as an improper fraction. 1 divided by 4 is 1/4. And then 3 divided by 4 is 3/4. So all my possible rational roots, again, rational, ratio, fraction. Fractions are possible rational roots. So that's the first difference. When we go to our synthetic division here in a second, what we're going to wind up having is, we're going to be trying all these numbers. While it is possible to do synthetic division with fractions, it's just a little more math. You might need to grab a calculator, but it's possible. What we're going to hope here is, again, since this is still a cubic function, we only got to divide it one time to get it down to be a quadratic. So what we're going to hope is, +1, -1, +3, or -3 works. Okay. Hopefully one of those 4 will work. And we don't have to bother with doing synthetic division with a fraction. So we're going to go start do our synthetic division, but the second kind of tweak is, again, we've seen a few problems like this where it's got that missing term. I have x cubed, I have x, I don't have x squared. I got to put in that placeholder, that 0x squared. So now when I go to do my synthetic, it's 4x cubed, 0x squared, -7x, and 3. Make my box. Again, I'm going to start with +1. I'm still going to circle it, even though y'all don't need to. Again, just so y'all can visualize it. All right. Drop my 4. Blue 4 times red 1. 4. 0 plus 4. 4 again. Blue 4 again times red 1. 4. -7 and +4 is -3. -3 times red 1 is -3. 3 minus 3 is 0. So we did synthetic one time. It actually worked first time this time. All right. So 1 is my root, because that's what I divided with. Factors, opposite sign, x minus 1. Go ahead and label them. Remainder, constant, x to the first, x squared. So when I divide, again, this is essentially what I've done. Divide 4x cubed minus 7x plus 3 by x minus 1. I get 4x squared plus 4x minus 3. So I guess third kind of tweak, if you will. Now that we get down to a quadratic, we have a coefficient in front of x squared for our quadratic. So we can't do simple factoring, but what we can do is that slide, multiply, factor, divide. So I'm going to slide 4 down here. All right, x squared plus 4x, -3 times 4 is -12. So slide, multiply, factor this. What can I multiply to get 12? That adds or subtracts to give me 4. 6 and 2. 6 times 2 is 12. 6 minus 2 is 4. So those are my two numbers. Again, ignoring the signs at first. Now I say, since 12 is negative, you know, when I multiply 6 and 2, one of those has to be positive, one has to be negative. They have to have opposite signs. And then to get positive 4, what am I going to have to do? 6 minus 2 or 2 minus 6? Of course, that would be positive 6 minus 2. So slide, multiply, factor. Last thing, divide. Divide by 4, divide by 4. You got to divide those constants by the number I slid. So again, when you're at this point, there's three things that could happen. You could have a fraction that divides evenly. I'm trying to turn my hands off. A fraction that divides evenly. That's what I don't have. Okay. You could have a fraction that is already simplified, which I don't have. I don't know why I have my ring finger up. Probably should have been this finger. So a fraction that doesn't simplify, which is not what I got, or fractions that do simplify. So I got to simplify these. 6/4 simplifies to 3/2. 2/4 simplifies to 1/2. So there's that. So the catch here is this is actually what's going to give me my roots. Okay. This is what's actually giving me my roots, which is what I'm going to talk about in a second. But these are not going to be my final factors. Okay. So, you know, above all the stuff in the middle, you know, if you're multiplying, even if you're multiplying 8 factors times each other, excuse me, I need a tissue. Sorry. If this hasn't been discussed previously with y'all, excuse me. Even if you're multiplying 8 factors, okay, you know, you could still say, you know, if you forget the stuff in the middle, you can say, all right, x, your first term, x times x times x, should give me the first term of my polynomial. And then if I multiply my last terms, -1 times 3/2 times -1/2, that should give me my last term. Okay, the stuff in the middle is going to be different, but that part's always kind of true if what I just said made sense. Okay, basically what I'm saying is, you know, I need x times x times x to equal 4x cubed, which it does not. I need -1 times 3/2 times -1/2 to equal 3. It does not. Okay. So I'll get to that in a second. But again, this is where I can actually get my roots. Okay. What cancels out 3/2? -3/2. What cancels out -1/2 is +1/2. And again, if you happen to look up here, there's -3/2, there's +1/2. There's rational roots right there. Okay. So I've got -3/2, +1/2. So to get the actual factors though, this is when after I can't simplify anymore, move the denominator back out in front, get 2x plus 3 times 2x minus 1. So that's what goes here. Okay. So again, if you kind of want to, you know, even the check I said now, you know, x times 2x is 2x squared. 2x squared times 2x. 2 times 2 is 4. X squared times x is x cubed. So there's my 4x cubed. -1 times 3 is -3. -3 times -1 is +3. Again, all the stuff in the middle, you know, it could be different depending on signs, but, you know, that's kind of a check that you can start with. If all your first terms multiply to give you your first term, all your last terms multiply to give you your last term. But anyway, so those are my factors, those are my roots. Again, there's no i's over here, so all my roots are real. And as far as rational or irrational, you know, again, rational could be represented by a fraction. 2 of them already are fractions. Rational, irrational, 1, whole number, integer, however you want to call it, is rational as well. So again, they are all real and rational, which you can write next to all three of those numbers. All right, so again, I will let this kind of sit for a few seconds. You know, again, the math, the synthetic part was the easiest part so far. It just had a little more math here with the slide, multiply, factor, divide, a little more writing. But everything worked out in the end. All right, so again, pause it real quick if you're still copying. So I'm gonna stop the share now. So there is number 5. I will record a second video for number 6, A, B, C, and D. Everything will get posted. Links will be added in the Canvas assignment, and we'll be good to go. So I'll see y'all in the next video. Until then, peace.